have Caleb read for us page 3. Caleb, can you read for us? Yeah. Coefficient. Good. Friction. All right. Out of you three, how many of you drive? Okay, good. Do you think it's easier to do left turns or right turns?
Left turns.
Left turns, right? You got much more space. You're on the left side already. You got your weight on the left side of the car. You have that leverage. Right turns, you're on the other side of the car, and you gotta guess what's on your right. You don't want to hit a curb. You don't want to hit a side. You don't want to hit another car. This is a turning car problem. And this problem is saying if you're going super fast and you need to make a turn, are you going to go off the road or are you going to stay on the road? Okay, you want to stay on the road, but you need to have enough force that keeps you on the road. Because when you turn, don't you want to be pulled out of your car when you're turning? Imagine you're going to a stoplight. It's turning yellow. You want to make the turn. So you make the turn. When you turn that wheel, don't you lean to the right by accident when you turn to the left? You guys know what I'm talking about? When you turn to the left, your body goes to the right, right? All the force. It's actually called inertia. Objects that are in motion, they want to stay in motion. Yeah, when you do donuts, right? Your body wants to get pulled out. But fortunately, your tires have enough grip to keep you on the road, right? That grip is a force. It's called friction force. So anytime you're driving and your car stays on the road, even though you're going super fast or you're making a sharp turn, your tires have a force called friction force that keeps it on the road. And that's what we're going to find. Okay? This car is going 55 kilometers per hour. So grab a pencil and label your car going 55 kilometers. The distance between the car and the center of this imaginary circle, because when you actually turn, your car is actually going in an imaginary circle. You just don't finish the circle. All right, Devin? So let's put our radius as 55 also. And that's the first way to look at the physics problem. You have to pretend you're on a plane and you see the car making the turn. And you're going to guess, does the car stay on the road or does it slip off the road? Because the friction force is good enough or it's too small. So how do you find friction force? Now we go to our second picture. You see how there's 4 arrows? Devin, tell me what FG stands for. Do you know? Do you remember? Force of what? It can be grams. Gravity. Because look, the arrow's pointing down. All 4 tires is going to be pulled down by gravity. So it's force of gravity, which is mass times the speed of gravity, or the acceleration of gravity. Elijah, you know what F and N is? Okay. F, it is an upward force. Okay. N stands for normal. So the force of normal is opposite of what? How much do you weigh? 215. Gravity's pulling you down with 215. But are you a puddle of skin and bone? You're not. So your body also has a force going against gravity. And it's exactly 215. So you have a force going up 215. You have a force going down. How much do you weigh? Yeah. 230. You have a force going 230 down and a force going 230 up. How about you? 140. So you have a force going down 140 and a force going up. Okay? That's your force gravity. That's your force normal. Now, this car isn't about just being parked. Okay, this problem would be done if it was a parked car. This car is moving. When the car turns, it wants to get away from this circle. Okay? That's why the tires start to screech. That's called applied force. We want to know if friction force is strong enough to keep the car on the road. So let's find friction force, okay? The first step is to find out what does the friction force have to equal to keep the car on the road? And that's called centripetal force. Remember this? I have to buy a tennis ball that's on a string or make it. But look at my pen, right? Elijah, you looking at my pen? So this pen is going around in a circle just like the car wants to go in a circle. But the car is not going to complete the circle. Otherwise, that's like a 360. The car just wants to make a left turn. Go to the store, go home, whatever. And that means the car has to have some kind of pulling motion called centripetal force. And that has to equal frictional force. So let's solve it. How do we find centripetal force? We use this. Centripetal force equals mass times volume velocity squared over r. But we don't know velocity in meters per second. So the second step is to turn our velocity into meters per second. What is our current kilometers per hour, Devin? 55. Good. Now multiply 55 times 1,000 divided by 360, Elijah. So grab a calculator. Times 1,000. No, it's right here. 55 times 1,000 divided by 360. 3,600. See the whole thing? Ten to the power of what? I get something else. Did you do 55 times 1,000? And then you hit equals, and then you hit divide by 3,600? I said 360, and then I corrected myself. But I should have just said it right the first time. So divided by 360. I did get 3,600. What is it? 1 point. Good. And we round to the 1.53 E1. Thank you. Let me print Jesus one of these. Devin, if you don't pass the test again, I'm going to say it's because you're on your phone. Okay? Did you write down what Elijah found for us? All right. Now let's do the third step. Third step is Caleb. So Caleb, Elijah found for us velocity, which we'll use to find the force needed for the car to stay on the road, which will equal our friction force. Or if the friction force is even higher, that's even better for the car. So let's plug in our numbers to find the centripetal force. What is our V, Caleb? Say the whole thing. E1, good. And then our R? 55. Grab a calculator. Follow us. Put in 1,000 times 1.53 second x minus 1 squared divided by 55. Tell me what you get. Times. Good. You did it. So that's how much force a car needs to stay on the road when it turns. That force has to be the same force for the friction force. Otherwise, the car will slide and hit another car. Any of you been in an accident yet? Car accident? Not yours? You've seen it? Okay. Oh, so you were riding in the car. What happened? Ooh. Were you okay? Okay. All right. How about you? What happened to you? A car hit you on your bike, and you broke something. The car had a scratch. This year, you recovered. You're playing football. That's amazing. Wow. Hit by a car, and then he plays football a few months later. Have you guys been in accidents?
Yeah.
What happened?
We got hit in the back. In your car? You were there too?
Okay.
I wasn't really scratched. I didn't scratch on my hair because I hit my head on like the stairwell.
Yeah. How'd you feel? How'd you feel here and here? Okay. Yeah, the seat probably hit you in the head, right? How about you? You been in an accident? You got rear-ended? Jeez. Their fault, right? Yeah. It's best to get hit from behind because that trunk is going to absorb the impact. If you are the one hitting somebody, that engine's going to come right at you, and that can crush bones. It could suffocate you. It's way worse to be the one hitting the person in front. Yeah, yeah. The receiver usually gets paid, but it helps to also have it on camera. So also, try to get that too. Well, there's those dash cams, right?
I got paid like $7,000 by insurance.
Okay. Yeah, thank God for that, right? Yeah, it takes forever, and you have to follow up.
You gotta follow the court dates and everything.
You guys sound like you're adults already. All right, Jesus, we're in day 14 and extra help folder number 3. Let's finish this before 10 o'clock, okay? So we found velocity. We found the force needed to keep the car on the road. Now we have to check, does the tire have enough friction force to equal the number of force that keeps the car on the road? Is it 4.26 E3 or more? We want that. We want super sticky tires. So let's plug in. This is how you use the equation for friction force. Friction force equals static coefficient, okay, fancy word for how much friction there is, times normal force. Remember, you are 230, you 215, 140, and then you were in the restroom. How much do you weigh? 195. So gravity pulls you down 195, but your bones and your muscles and skin also push up 195. Okay, that's the normal force. So let's plug in. Jimenez, if you look at our A, what's the static friction coefficient? What's given to us? 0.65. So that's what we put for this. I know this doesn't look like a static friction abbreviation. It's Greek. So we just have to put in 0.65 for that. All right? Long way to say that. And now we multiply that to the negative mass. What's the mass, Jimenez? You see it? What's the mass in the problem? $55 is M, which looks like mass, but M is meters. kilograms is mass, which is 1,200. All right. Devin, grab a calculator. You're going to put in 0.65. That's supposed to be a 65. Let's do that. Put in 0.65 times negative 1,000 times negative 9.8. Where did we get these numbers? This is the mass of the car, and this is the acceleration of gravity, right? That's just right here. M times G is our force. So force normal is negative M times G. So that's why this is here. This is 0.65. We took it from here. Caleb helped us see this, or Jimenez helped us see this. It's plugged in. So what do you get, Devin?
6.4. Are we rounding?
We're rounding to the hundreds, which is this.
36.37.
Nice. Well done. All right. You guys are being scientists. This is the friction force of our tires. Is it enough to equal our force needed to keep the car on the road? It is. Therefore, driver lives, no insurance payments needed, no damages, car will go on. It will make the turn. So circle, it will make the turn. Okay, last part is the icy road. So let me scoot this paper down. Now, in California, it doesn't really ice that often. So, unless you travel to Big Bear. You guys heard of hydroplaning? So hydroplaning is when water is raining when rain hits the road, there becomes a layer of water that just kind of sits there. You can think of it as a puddle if you want, but you slide. When your tires go over it, you're going so fast that your car sometimes lifts up because of the water, and then it acts like a boat. It's called hydroplaning. So a lot of the times your freeways will have these like grooves so that the hydroplaning is minimized. But we've been having floods in California. And so usually that's a no-fault accident, and your insurance should cover it. But you just have to pay the insurance company more later. Your premium goes up. Yeah, whether you're at fault or not at fault, you end up paying more. Yep. You pay your own insurance? Okay, yeah, sooner or later. How many of you work? You guys are in sports? You work a little bit? Insurance, if you get good grades, it actually lowers your insurance payments. Okay? Keep that in mind. Also, stay out of trouble, right? No criminal record. Insurance payments are lower. Girls actually get lower insurance payments because statistically, boys get in more accidents. So automatically, you're a guy, you get the higher rate. You have to pay more. It's unfair, I know. Also, if you buy a truck, it's going to be a higher insurance payment. How many of you knew that? Not a luxury truck. I'm talking like regular trucks. Statistically, truck drivers, they get in more accidents. Okay? I think it's a mental thing. You're just like, I'm a truck, I'm going to go first. I'm a truck, I'm bigger than you, I'm going to go first. And it's true, right? Yeah. Yeah, and that's very expensive to fix. So, if you ever hydroplane, you got to consider, okay, this is what it's going to cost me from now on, right? So go slower in the rain, especially the first 5 minutes of rain and the last 5 minutes of rain. That's the most slippery, because that puddle is just starting to settle, and your car's going slow. Yeah, just go slow. All right. That being said, will the car crash or not? Let's calculate it. The friction of ice is 0.2. I'd say a friction of a puddle is like maybe 0.5. Not as good as a road, but not as slippery as ice. So let's plug in our static coefficient for ice. Whose turn is it? Is it Devin? No, Devin solved it for us. Elijah, what's our coefficient for ice? it's actually mu of static friction. It's so annoying. Doesn't even look like static friction, but you just have to accept it. What is it? 0.20. So plug that in. 0.20 times, what's the mass? All right. Elijah, you want to do the calculation? Okay. So you're going to plug in 0.2 times negative 1200 times negative 9.8. Done?
Yeah.
Okay, great. I have to check your answers later. But thank you. What is it? 2 point. Good. But when we write it, we can say E. What? E3. Good. Caleb, when this car is going 55 kilometers per hour on ice, does it stay on the road?
Yeah. Oh, wait.
It's got to equal this or more.
Has to equal that more?
Yeah.
No, it's not.
It's not.
It's not fair.
The car will skid off the road into a tree. That's probably like one of the worst ways to get an accident because that
tree is not breaking.
the roots are too deep. The car will crumble. Okay, that's it. We're done. So tomorrow on Monday.